Hello everyone, welcome to solve this Math Olympiad algebra problem, and we have 3 to the power of m minus 3 to the power of n equals to 234, where our m and n belongs to positive integers and m must be greater than n. So now we solve this problem for the values of m, and remembering that these are the restrictions in this question. So here we know that our m is greater than n or n is lesser than m, so that first we rewrite this equation as 3 to the power of m minus n plus n. Because our n is lesser than m, so we add and subtract this m here, and we write it as minus 3 to the power of n equals to 234. So now in the next step we use here the nice exponential law, and you know about this law. If we have a to the power of m plus n, it is equals to a to the power of m times of a to the power of n. So now we use here this nice exponential law in the left hand side and to the first term. So we rewrite this term as 3 to the power of m minus n, and multiplied by 3 to the power of n, minus we have 3 to the power of n equals to 234. So in the next step, you see here we have 3 to the power of n with a common factor, so that we take it common and we write the remaining terms are 3 to the power of m minus n minus 1 equals to 234. So now you focus on the left hand side, and we have two factors are multiplied by each other, and similarly in the right hand side we have only one factor. So now here first we find the factors of 234 by using this method. So now first we divide this by 2, and we have 2 ones are 2, 2 ones are 2, and we carry 1, and 2 sevens are 14. And now we divide it by 3, and we have 3 threes and 9, and we carry 2, and 3 nines are 27. We again divide it by 3, and we have 3 ones are 3, 3 threes and 9, and we divide it by 13, and 13 ones are 13. So we write this 234 as 3 multiplied by 3 multiplied by 2 multiplied by 13, and we write 3 times of 3 as 3 square, and 2 times of 13 equals to 26. And in the left hand side we have 3 to the power of n into 3 to the power of m minus n minus 1. So we have this equation. So now we have time to compare both of the sides. So now we divide this in two cases. So our first case is we compare the left hand side to the right hand side in this way. So we take 3 to the power of n equals to 3 square, and we take the second factor 3 to the power of m minus 1 minus 1 equals to 26. And similarly in the second case we compare 3 to the power of n equal 26, and this factor equal 3 square. So we write it as 3 to the power of n equals to 26, and we have 3 to the power of m minus n minus 1 equals to 3 to the power of 2. But here you remember one thing is that we have some restrictions which is right in the question statement. So you know that our n and m and n must be a positive integer, and m must be greater than n. So if you focus on the second case, and you see that in this case we cannot get the positive integer solution. If you can if we have the restriction in the given question is that if our m and n belongs to real numbers, then we easily solve this case also. But because we have the restriction to find positive integer solutions, so this case cannot gives us the positive integer solution, so that we rejected this case, and we can just proceed here this case only. And in this case we first solve this equation, and in this equation you see here we have bases on both of the sides are same, so we equate its exponents. So our exponent is n equals to 2, so we easily find the value of n here. And now we solve this equation. So in this equation, first we move this minus 1 to the right hand side, and it will be written as 3 to the power of m minus n equals to 1 plus 26, because this is minus 1, and when we move to the right hand side it will becomes plus 1, and we have 1 plus 26 equals to 27. In the left hand side we have 3 to the power of m minus n. So now we rewrite this 27 as 3 to the power of 3, because we know that 3 to the power of 3 equals to 27. And in the left hand side we have 3 to the power of m minus n. And now you compare both of the sides, and you see here we have bases on both of the sides are same, so we again equate its exponents, and its exponents are m minus n equals to 3. But here we already find the value of n, and the value of n is equals to 2, so we substitute this value here and we get m minus 2 equals to 3. We move this minus 2 to the right hand side, and it will becomes m equals to 3 plus 2, and 3 plus 2 equals to 5. So this is the value of m. So finally we have two values of m and n, and these values we write it here. Our m equals to 5 and n equals to 2. So now you check both of the values. So both of the values are positive integers, as well as our m is greater than n. So it must be satisfied the given conditions. So now we check these values, is these values are satisfied our given question statement or not. So that here we copy down the given question statement. So our given question statement is 3 to the power of m minus 3 to the power of n equals to 234. So this is the our given question statement, and now we substitute the values of m and n here, and we check that is these values satisfied this question or not. So here we have 3 to the power of m. So over m is 5 minus 3 to the power of n, and over n is 2 equals to 234. And then we know that 3 to the power of 5 equals to 243, and we know that 3 square equals to 9, and this whole equals to 234. And we know that 243 minus 9 equals to 234 equals to 234. So this shows that the values of m and n must be satisfied our given question statement. So this is the final values of m and n, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.